Hello students. Next in the two-port networks, after we have studied the Z transform, the basics of Z transform, we have to study two conditions. One is the condition of reciprocity and the second one is the condition of symmetry. Now first condition of reciprocity. What do you mean by reciprocity? See, if suppose we are having a circuit, a two-port network or a two-port circuit, then in that two-port circuit, so this is the two-port circuit or two-port network, we are having the input and the output port. This is the output port and this is the input port. I already told that if you are going to have a circuit, a big circuit, what generally people do is they divide it into several smaller two-port networks and they interconnect these two to find out what the total circuit will look like. What reciprocal network means is, here we have used this as input and this as output. If you are having a two-port network in which the input and output can be interchanged, that means you just simply use this side as the input and this side as the output, then you are able to get the same condition or you are able to get the same working that you had when you use this side as the input and this side as the output. Then you will be able to say that the circuit is reciprocal. That means it can be used in this direction as well as it can be used in this direction, because in both ways this is going to work same. Now for example, see, if I am trying to let's say if I'm trying to have a circuit in which it's a, let's say, a transistor circuit. So here is my input and this is my output, and this we all know is basically a amplifier kind of circuit. Let's say that it's just amplifying whatever is going to be given at the input. Of course there has to be some biasing and all, but that I'm not going to take now. Just imagine that this side is the input and this side is the output. So this side, whatever signal you give, that signal is getting amplified and you are getting it here. So some amplification multiplied with x. So whatever x you are giving, you are getting an amplified version of that x here. And that is this circuit, and that can be drawn as a two-port network. One is the input side where you are giving x and the output side where you are receiving ax, and the other terminals are grounded. Okay, so this is similar. Now you know that when it is working in this direction, it is amplifying. Will it amplify in this direction? That means if you give your, instead of output, if you give input here, will you get the output here? No, we all know that that condition will not happen. Why? Because we know the working of transistor, it does not work in that way. For making it work as an amplifier, you have to give only input here and here you take the output. So this circuit is not reciprocal. It's not reciprocal. But there are networks or there are circuits which are, basically reciprocal in nature. That means they are, or they can be used in both the direction. That means you can use this side as input and this side as output, or even you can use this side as input and this side as output. So if you want to know that a circuit or a two-port network, if it is reciprocal or not, if you want to know if a circuit is reciprocal or not, then by looking at the Z parameter you will be able to find out if the circuit is reciprocal or not. Okay, you will be able to find out if the circuit is reciprocal or not. Now let me draw a simple example, another example. Suppose you are having a circuit in which this is 2 ohms, this is 2 ohms, this is again 2 ohms, and this is what is the two-port network looking like. Now have a look here. If you are going to give an input here and get an output from here, the same thing will happen if you are going to give an input here and you are trying to get an output here. Why? Because the circuit looks the same. And from this direction or from that direction, the circuit looks the same. So this is a reciprocal network. This is a reciprocal network. That means you can, you can take this circuit and if suppose you had used this side as input and this side as output, then you can use the same circuit, but next time you can take this side as the input and the other side you can take the output. So what we have done, the input and output are interchanged. Those kinds of circuit are called as a reciprocal circuit or a reciprocal network. And by looking at the Z parameter, we can say if a circuit is reciprocal or not. So let us find out what or how do we get from the Z parameter if a circuit is reciprocal or not. Okay, so the condition of reciprocity, first is we will write the statement that a circuit is, let me use a different color, a network, a two-port network is reciprocal if the ratio of excitation at one port to response at the other port, to response at the other port, if the ratio of the excitation of one port to the response at the other port is same if the excitation and response if the excitation and response are interchanged. Okay, that means what? It means that suppose if you are having a two-port network as it is shown here, okay, as it is shown here, I will draw one more two-port network, the same two-port network. Okay, and this time I am going to again the input side and this is the output side and this is the two-port network, the same two-port network. Okay, so what it says is, what this statement is saying is, if suppose you are able to or you are exciting one port of this network, so what is the excitation? The excitation here is this voltage you are giving. So this is the excitation voltage you are giving, and because of which there is some current I1, and in this side you are trying to measure the current using an ammeter. Okay, let's say you are using an ammeter here. Ammeter is for measuring how much current is passing through this. So this is the I2. Okay, this is I2, and you are trying to measure I2 with the help of this ammeter. So you might be thinking, here I have drawn the arrow like this, here I have drawn in the opposite direction. Oh, is there any problem? No, the only thing is that whatever I am going to measure, I have to take the negative of that because the direction is changed. So okay, now we know that the ammeter is having zero internal resistance, so the voltage here will be zero. So the voltage here V2 will be equal to 0, and here Vs is the same voltage that we will be having for V1. So plus minus V1 is same as Vs. Okay. If this is the condition, and now I am talking about interchanging it, that means if I am now going to take in the second case, if suppose I am going to take the voltage this side, that means the source this side plus minus Vs I am going to take this side, because of which there is a current I2, and here I am trying to measure with the help of ammeter. Here I am trying to measure the response with the help of ammeter of what is the current I1. Then I have interchanged the excitation and response in both the circuit. Okay, so here again the voltage will be this side because the ammeter is having zero internal resistance. V2 V1, this is V1, sorry, this is V1. So V1 will be equal to 0. So now the statement is saying that if you are going to get the ratio of excitation at one port, what is the excitation? V1. So if you are going to get V1 ratio of excitation to response at the other end is what? Minus V2. So V1 minus I2, if it is same as the excitation and response. So what is the excitation here? Here it is plus minus V2, and that is equal to Vs. Okay, so excitation V2 divided by response. What is the response? Minus I1. So what it tries to say is, if this condition is satisfied, what is that? The ratio of excitation to response, where excitation is at one port and the response is at other port. So this is at port 1, this is at port 2. If you are interchanging the excitation, see here we had the excitation here, we have, and the response here. In the second case we interchanged, we took the excitation and kept it here, and we took the response and kept it here. So we have interchanged the excitation and response. So if you interchange the excitation and response like this, and if you are going to get the same answer, then you say that the circuit is reciprocal. Okay, so let us see if we are able to reach this. So when I am going to do okay, yeah, so Z parameter equation is basically given by Z parameter equation is basically given by V1 is equal to Z11 of I1 plus Z12 of I2. V2 is going to be equal to Z21 of I1 plus Z22 of I2. Okay, now have a look here. Here when I am going to take V2 is equal to 0, that means I have short circuited this one, isn't it? So in this situation V2 is equal to 0, and in this situation V1 is equal to 0. This side is equal to 0. So this I have to write, okay, this I have to write that in one case I have made V2 is equal to 0, in the other case I have made V1 is equal to 0. Now if I am going to take V1 is equal to 0 in one case, okay, then from this equation I can put V1. So for this case V2 I have to make 0. Okay, so let me try to find out this one. What is V1 by minus V1 by minus I2? Let me try to find out V1 by minus I2. Let me first try to find out this one. For that, what I have to do with V2 is equal to 0. So if I am going to put V2 is equal to 0, then I will get V1 is equal to Z11 I1 plus Z12 I2. The first equation is totally unchanged. The second one, V2 is equal to 0, and Z21 I1, okay, Z21 I1 plus Z22 I2. Then from this equation I can further get the value of, see, I want the equation in terms of V1 by I2. So from here I can replace I1. So I will say therefore I1 from this equation. Okay, I1 is going to be equal to minus of Z22 I2 divided by Z11, Z21, sorry, from this equation itself. Therefore, V1, and now I am going to substitute I1. What is I1? So this is Z11, and then the remaining portion is minus of Z22 I2 by Z21 plus Z12 I2, where I can take I2 common and I can write this as minus Z11 Z22 plus Z12 Z21 divided by Z21, that is multiplied with I2. Okay, therefore V1 by I2, okay, V1 by I2 I will directly get minus Z11 Z22 plus Z12 Z21 divided by Z21, and if I am trying to take the minus of this, then this will become plus and the second value will become minus. The second value will become minus. So that, let me write, this is going to be minus. So this is the first value that I have found out with the condition that I am taking V2 is equal to 0 from this equation. See, from this equation only we have got it. So the left hand side we have got. Now we have to equate it with the right hand side. So what is the right hand side? So the right hand side, I will write here for finding V2 by minus minus I1, V2 by minus I1, V2 by minus I1 when V1 is equal to 0. This is the second condition that I want to find out. Again I will use the same equation, the Z parameter equation, but now I have to write V1 is equal to 0. So 0 is equal to Z11 I1 plus Z12 I2, and the second equation is V2 is equal to Z21 I1 plus Z22 I2. So now I want the equation in terms of V2 and I1. So here V2 is there and I1 is there. I want to replace this I2 from where? From this equation. So that is what I will do. So okay. So now I am going to start that. So from here I have to get rid of I2, isn't it? So I will get I2 is equal to minus Z11 I1 divided by Z12. Therefore V2 is going to be equal to Z21 I1 minus of Z22 I2. I am going to substitute this, that's why I put the minus there. Then Z11 I1 divided by Z12, from which I can take I1 commonly outside. So I will get Z21 cross multiplied with Z12 minus Z22 Z11 divided by Z12 I1. Therefore, from here I will get V2 by I1 is equal to Z21 Z12 minus Z22 Z11 divided by Z12. Okay, but I have to find minus of that. So therefore minus of V2 by I1 when V1 is considered as 0 is going to be, I just put a minus here, so Z11 and Z22 will come, the product of Z11 Z22 will become positive, so I will write that first. I will write this part first, and then the other part is negative, so minus of z12 and z21. I just written the same thing, but I have interchanged it. Okay, and then in the denominator it is z12. Okay, so let me put this also in the box. So this is the second one that I have found out. And what does condition of reciprocity says? According to the statement, the ratio of excitation versus response at the opposite ports should be same if it is. So this equation I am going to write as equation 1. Remember, this set of equation I am going to write as equation 2. And this I have got is 3, and this I have got is 4. Now what does this say? This says that for equation 1, both 3 should be equal to 4. So I will write it like that. For equation 1 to be true, equation 3 should be equal to equation 4. Now look at equation 3 and 4. Okay, if you would look at the numerator, z11, z22, same is here, z11, z22, minus of z12, z21, that means here also z12 and z21 is there. Now look at the denominator. In the denominator, z21 is there and here z12 is there. Two different quantities, isn't it? Therefore, if 3 and 4 should be equal, if you want 3 and 4 to be equal, the required condition is, so for equation 1 to be true, 3 is equal to 4, for which z21 should be equal to z12. Therefore, the condition finally it says that for reciprocity or for a circuit to be reciprocal, the condition is that z21 should be equal to z12. That means if you are able to find out for any circuit that z21 is same as z12, so where do we write z21 and z12? Have a look here. Z11 is written here, z12 is written here, z21 is written here, and z22 is written here. So what it says is that if this value is same as this value in the z parameter, then the circuit is reciprocal. You don't have to do anything else, just look at the z parameter. If this value is same as this value, then that circuit is reciprocal. Okay, so let us look at the problem that we previously did. You remember the first problem that we did, this one, z parameter. Let's look at its answer. What is the answer? The answer here is this one. This is the z parameter. Now look here, z12 and z22, are they same? They are the same. And since they are the same, we can say that this circuit is indeed reciprocal. This circuit is indeed reciprocal. Okay, we'll take the second example that we did, this one. Is this going to be reciprocal? Let's look at its z parameter. This value and this value both are same, isn't it? Both are same. Hence this network is also a reciprocal network. The previous one also is a reciprocal network. So just by looking at the z parameter, we will be able to find out if the circuit or if the network is reciprocal or not. Okay, so that was the condition of reciprocity for z parameter. Next we have to look at the condition of symmetry. The condition of symmetry. The condition of symmetry is, the statement is this: for a network to be symmetrical, the voltage to current ratio at one port should be the same as the voltage to current ratio at the other port with one of the ports open circuited. That means, see, if I am going to give a voltage here, plus minus, this is suppose Vs, and because of which there is a current I1 which is flowing here, and we are giving this circuit as open circuit. So when we make this as open circuit, plus minus V2 is there and I2. Now when we are saying that this is open circuited, this must be open circuited, then I2 should be equal to 0. And now we are going to interchange it. In the second case, we are going to consider that the voltage source is getting applied here, plus minus Vs is getting applied here, because of which there is a current I2, and this side we have made it open circuited. That means your I1 is going to be equal to 0, and there is a voltage plus minus V1, and this is now open circuited. So when one side is open circuited, the other side you are trying to find out what is the ratio. See, what is the ratio, which ratio, voltage to current ratio at the same port. So what this says is that if, now let me draw the voltages here. So this is plus minus V1 and this is plus minus V2, correct? So what it says is that the ratio V1 by I1, okay, V1 by I1 should be equal to V2 by I2 in the second case, V2 by I2 in the second case, but there is this condition set. What is, one of the port is open circuited, correct? One of the port is open circuited. That means in this case you have made the second port open, so this is I2 is equal to 0, and in this case it is I1 is equal to 0. So if you are able to find out how to make these two quantities same, then you have got the condition for symmetry. Okay, we have got the condition for symmetry. So let us do it. Z parameter. The Z parameter is given by, the Z parameter, it is given by the equation we all know, V1 is equal to Z11 I1 plus Z12 I2. Remember, you have to remember this equation by heart. Z21 I1 plus Z22 I2. So now we have got this set of equation, which is the Z parameter equation. And now first I have to find out the first quantity, which is in the left hand side. So for V1 by I1 with I2 is equal to 0. This is what I want to first find. Okay, for doing this, so I make I2 is equal to 0. See, if I take the first equation, okay, so this is equation 1, suppose. This is equation 2. Now this is equation 2, which I am going to split into two parts. I will write this as 2a and this as 2b. So 2a, 2b. So from 2a, if I2 is equal to 0, what I will get? I will get V1 is equal to Z11 I1, correct? Therefore, V1 by I1 with I2 is equal to 0 is going to give me the value Z11, correct? So this I will put it in the box. This is very simple. We have got the answer that it should be Z11. Similarly, for the second case, for the right hand side of the equation, for V2 by I2, when I1 is equal to 0, I will use equation 2b. So from 2b, if I am going to take I1 is equal to 0, then I will get, then what is the equation I get? I get V2 is equal to Z21. Sorry, I am taking I1 is equal to 0. No? So I will get, the first term is going to be 0, the second term is going to be Z22 I2. Therefore, I can say that V2 by I2, when I make I1 is equal to 0, is going to be Z22. This is going to be my second equation. This is going to be my second equation. So I have got the two conditions. Now this I will, let me name this as 3 and this as 4. Okay, let this equation be equation 3 and this as equation 4. So for 1 to be true, 3 should be equal to 4, for which if 3 should be equal to 4, what should be the condition? For which Z11 should be equal to Z22. Therefore, now I will write, therefore, for a circuit or network, for a circuit to be symmetric, the condition is Z11 should be equal to Z22. Okay, that means if we are going to take the Z parameter, we know that Z parameter is written as Z11, Z12, Z21 and Z22. So what the condition of symmetric says? The condition of symmetricity says that this value should be same as this value. Then you will be able to say that the circuit is symmetric. Now let us take the examples. Okay, the examples that we had taken, let us take this one. See, this is the final Z parameter that we got, correct? Look here, is this same as this one? One is 11 by 5 and the second one is 6 by 5. Are they same? They are not same. So can we say that this circuit is symmetric? This circuit is not symmetric. Similarly, let me take the next one. Look at this answer. Are this and this the same? They are not the same. So the circuit is not symmetric. Okay. Now, I explained you exactly what is symmetricity. I just like that I want to explain you what is, sorry, I just explained you reciprocity very correctly. I want to explain the physical meaning of symmetricity. See, if suppose you are going to have a network like this, okay, suppose this is let's say 4 ohms, this is 1 ohm and this is also 1 ohm. Okay, now look here, this 4 ohm I can divide it into two parts. That means, let me draw it like this, let me redraw it. This is 1 ohm itself, this is going to be 2 ohms in series with another 2 ohm. So now the 4 ohms I have split up into two parts, isn't it? One is 2 ohms, another is another 2 ohms. Now you look at this circuit. Look at this circuit. I can draw a line. I can draw a line right in between this, and you will feel that in this side, whatever is there, it is the mirror image of this side. It is the mirror image of the other side, isn't it? So here you are having 2 ohms, here also you are having 2 ohms, here you are having 1 ohm, here also you are having 1 ohm. So the circuit looks symmetrical about this axis. So this I will call as axis of symmetry. So the either side of this axis, you will find that the circuit looks exactly the mirror image of the other. So any circuit you are able to draw, or you are able to find out a line, an axis of symmetry across which the circuit looks to be having a mirror image of each other, then that circuit is a symmetrical circuit. So then this will be called as a symmetrical circuit. Let me show you another example. So here suppose it is 1 ohm, I am having another 1 ohm here, and suppose here I am having a 1 ohm resistor. So can I draw an axis which exactly gives a mirror image? You may feel that it is not possible. But have a look here. This 1 ohm resistance, I can write it as a parallel combination of two resistances. So 1 ohm I am going to draw here, that is not going to change. Similarly 1 ohm I am going to draw here, that is also not going to change. Whereas the 1 ohm that I am having in between, that can be drawn as a parallel combination of 2 ohm with another 2 ohm. We know that 2 parallel with 2 is going to give me 1. So this 1 ohm resistor, I can split it up as 2 ohms parallel with another 2 ohms. Okay. Now see, you can draw an axis of symmetry from which if you look one side, it is the mirror image of the other side. So this also is a symmetrical circuit. This also is a symmetrical circuit. And that is why we use this concept of symmetry, and there is no need for you to draw like this always and find out. No need to draw like this. All you need to do is find the Z parameter. In the Z parameter, just look if Z11 is same as Z22. If that condition is satisfied, then the circuit is symmetric. If Z12 is same as Z21, if these both are equal, then you have the circuit to be reciprocal. That is the condition that we previously saw. So let me summarize that. The parameter, I will draw always a table like this. The parameter is going to be having an equation. So the equation is V1 Z11 I1 plus Z12 I2. Then the second equation is V2 is equal to Z21 I1 plus Z22 I2. So this was, let me use a different color. This was the parameter equation. Okay, so this is the parameter equation. The second one I want to know is what is the condition for reciprocity. For reciprocity, what is the condition? For symmetry, what is the condition? Okay. So this is the Z parameter. Let me write that also. I should not miss that. This is the Z parameter. So for Z parameter, the condition for reciprocity is that Z12 should be equal to Z2. And for symmetry, the condition is that Z11 should be equal to Z22. This I will totally, write it in form of a table. So let me draw the table. So I will draw it like this. Okay. So I am having 4 parameters to be discussed. So for each of those parameters, I will follow the same procedure. I will find out its equation. I will find out the condition for reciprocity, for symmetry for each of those parameters. I was starting with the Z parameter. After this, I will look for the Y parameter. Okay, and then I will go for the hybrid parameter, and then after hybrid parameter, which is the third parameter, I will go for the last parameter, which is the transmission parameter. So each one by one, for each case I will find out. So this was for Z parameter. Similarly, I will find for Y parameter, and similarly I will find for the hybrid parameter, which is also called as small h parameter. and similarly for the transmission parameter, or what is called in short as T parameter. So for all these four parameters, I will find the same thing. I will find out what is the equation for the parameter. I will find out the condition for reciprocity. I will find out the condition for symmetry. And this you should not forget. It means this formula usage you should not forget. Okay, thank you.